When installing a transfer switch and dealing with circuits originating from both a main panel and a subpanel, it is essential to understand the requirements for proper and safe operation. You must move both the hot wires and the neutral wires from the main panel to the transfer switch. The purpose of the neutral wire is to provide a return path for the current in an alternating current circuit. Without a properly connected neutral wire, the circuit will not function as intended. The electrical current needs a complete loop to flow, starting from the source, passing through the load, and returning to the source. The hot wire provides the path from the source to the load, while the neutral wire provides the return path from the load back to the source. If the neutral wire is not connected, the circuit is incomplete and no current will flow. In an electrical system, the neutral wire is typically bonded to ground at the main service panel. This bonding ensures that the neutral wire is at or near ground potential, which is crucial for safety. The ground wire provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and disconnecting the circuit. This protects against electrical shock and prevents damage to equipment. The National Electrical Code, or NEC, provides guidelines and regulations for electrical installations to ensure safety and proper functioning of electrical systems. It is important to adhere to these guidelines when installing a transfer switch and wiring circuits. When you are transferring circuits from the main panel to the transfer switch, you must move both the hot and neutral wires to maintain the integrity of the circuit. The number of circuits you are transferring, 7 from the main panel and 5 from the subpanel, does not change the requirement to move both the hot and neutral wires. Each circuit requires both a hot and a neutral wire for proper operation. In addition to the hot and neutral wires, you also need to connect a ground wire to the transfer switch. The ground wire provides a path for any stray electrical current to flow back to the ground, providing an extra layer of safety. The ground wire is typically connected to a grounding electrode system, which can include grounding rods, metal water pipes, or other approved grounding methods. The grounding electrode system ensures that the electrical system is properly grounded, which is essential for safety. Here is a more detailed explanation of the components and considerations involved when installing a transfer switch. Firstly, consider the purpose of a transfer switch. A transfer switch is used to switch between two power sources, typically the utility power and a backup generator. When the utility power fails, the transfer switch allows you to switch over to the generator power, providing continuous power to essential circuits. Secondly, there are different types of transfer switches available, including manual and automatic transfer switches. A manual transfer switch requires you to manually switch between the two power sources, while an automatic transfer switch automatically switches over to the generator power when the utility power fails. Thirdly, when selecting a transfer switch, it is important to consider the size and capacity of the switch. The transfer switch needs to be able to handle the electrical load of the circuits you are transferring. You need to calculate the total amperage of the circuits and select a transfer switch with a capacity that meets or exceeds that amperage. Fourthly, before installing the transfer switch, it is important to disconnect the power to the circuits you are working on. This can be done by turning off the circuit breakers or removing the fuses that supply power to those circuits. Always verify that the power is off before starting any electrical work. Fifthly, identify the circuits you will be transferring from the main panel to the transfer switch. These are the circuits that you want to be powered by the generator when the utility power fails. It is important to select essential circuits such as lighting, refrigerators, and heating systems. Sixthly, label each of the wires that you will be disconnecting from the main panel. This will help you to keep track of the wires and ensure that you reconnect them correctly to the transfer switch. Use wire labels or colored tape to identify each wire. Seventhly, disconnect the hot and neutral wires from the main panel. Use a screwdriver to loosen the screws that hold the wires in place and carefully pull the wires out. Be sure to keep the wires organized and labeled. Eighthly, connect the hot and neutral wires to the transfer switch. The transfer switch will have terminals for connecting the wires. Connect each wire to the corresponding terminal, making sure that the connections are tight and secure. Ninthly, connect the ground wire to the transfer switch. The transfer switch will have a ground terminal for connecting the ground wire. Connect the ground wire to the ground terminal, making sure that the connection is tight and secure. 10thly, connect the transfer switch to the generator. The transfer switch will have terminals for connecting the generator power. Connect the generator power wires to the corresponding terminals, making sure that the connections are tight and secure. 11thly, test the transfer switch to make sure that it is working properly. Turn on the generator and switch over to the generator power. Verify that the circuits that you transferred are now being powered by the generator. 12thly, inspect the wiring connections to ensure that they are tight and secure. Loose connections can cause problems such as voltage drops, overheating, and even electrical fires. Use a screwdriver to tighten any loose connections. 13thly, follow the manufacturer's instructions for the transfer switch. The manufacturer's instructions will provide specific details about the installation and operation of the transfer switch. It is important to read and follow these instructions carefully. 14thly, if you are not comfortable working with electricity, it is best to hire a qualified electrician to install the transfer switch. Electricity can be dangerous, and it is important to have the work done by someone who is knowledgeable and experienced. 15thly, ensure that the transfer switch is properly grounded. Grounding is essential for safety and helps to prevent electrical shock. The transfer switch should be connected to a grounding electrode system, which can include grounding rods, metal water pipes, or other approved grounding methods. 16thly, check the voltage and amperage ratings of the transfer switch. The transfer switch should be rated for the voltage and amperage of the circuits that you are transferring. Using a transfer switch that is not properly rated can cause damage to the switch and the connected equipment. 17thly, consider the location of the transfer switch. The transfer switch should be located in a dry, accessible location. It should not be exposed to moisture or extreme temperatures. It should also be easily accessible for maintenance and repairs. 18thly, use the correct size and type of wire for the connections to the transfer switch. The wire should be sized according to the amperage of the circuits that you are transferring. It should also be of the correct type for the application, such as THHN or THWN wire. 19thly, protect the wiring from damage. The wiring should be protected from physical damage such as abrasion, cuts, and impacts. This can be done by using conduit, cable trays, or other protective measures. 20thly, label the transfer switch and the connected circuits. This will help you to identify the transfer switch and the circuits that it controls. Use labels that are clear and easy to read. 21stly, keep the area around the transfer switch clean and free of obstructions. This will make it easier to access the transfer switch for maintenance and repairs. 22ndly, inspect the transfer switch regularly. Inspect the transfer switch for any signs of damage or wear. Check the wiring connections to make sure that they are tight and secure. Clean the transfer switch to remove any dust or debris. 23rdly, have the transfer switch inspected by a qualified electrician on a regular basis. A qualified electrician can identify any potential problems and make repairs as needed. 24thly, keep records of all maintenance and repairs performed on the transfer switch. This will help you to track the performance of the transfer switch and identify any recurring problems. 25thly, familiarize yourself with the operation of the transfer switch. Know how to switch between the utility power and the generator power. Know how to troubleshoot any problems that may arise. 26thly, keep a copy of the manufacturer's instructions for the transfer switch. The manufacturer's instructions will provide specific details about the operation and maintenance of the transfer switch. 27thly, follow all applicable electrical codes and regulations. The National Electrical Code, or NEC, provides guidelines and regulations for electrical installations to ensure safety and proper functioning of electrical systems. It is important to adhere to these guidelines when installing and operating a transfer switch. 28thly, be aware of the potential hazards associated with electricity. Electricity can be dangerous, and it is important to take precautions to avoid electrical shock and other injuries. 29thly, If you are not sure how to install or operate a transfer switch, it is best to consult with a qualified electrician. A qualified electrician can provide you with the information and assistance you need to ensure that the transfer switch is installed and operated safely and properly. 30thly, when connecting the neutral wires to the transfer switch, ensure that you are not creating a situation where the neutral is bonded to ground in more than one location. This is known as a floating neutral and can create dangerous conditions. The neutral should only be bonded to ground at the main service panel. 31stly, double check all wiring connections before energizing the circuit. Make sure that all screws are tight and that the wires are properly seated in the terminals. Loose or improperly connected wires can cause problems such as voltage drops, overheating, and electrical fires. 32ndly, use a multimeter to verify the voltage and amperage of the circuits that you are transferring. This will help you to ensure that the transfer switch is properly rated for the load. 33rdly, consider using surge protection devices to protect the circuits that you are transferring. Surge protection devices can help to protect against voltage spikes and surges that can damage electronic equipment. 34thly, when selecting a transfer switch, consider the number of poles. A single pole transfer switch switches only the hot wire, while a double pole transfer switch switches both the hot and neutral wires. For most applications, a double pole transfer switch is recommended to provide a more complete isolation of the circuit. 35thly, when installing a transfer switch in a subpanel, it is important to ensure that the subpanel is properly grounded and bonded. The subpanel should have a separate grounding electrode system that is connected to the main grounding electrode system. 36thly, when transferring circuits from a subpanel, you need to consider the ampacity of the feeder conductors that supply power to the subpanel. The feeder conductors should be sized to handle the total load of the circuits that are connected to the subpanel. 37thly, when using a generator with a transfer switch, it is important to ensure that the generator is properly sized for the load. The generator should be able to provide enough power to handle the total amperage of the circuits that are connected to the transfer switch. 38thly, when connecting the generator to the transfer switch, use a properly sized and rated cord or cable. The cord or cable should be long enough to reach from the generator to the transfer switch, and it should be protected from damage. 39thly, when operating a generator, follow all safety precautions. Generators produce carbon monoxide, which is a deadly gas. Operate the generator in a well-ventilated area and install a carbon monoxide detector in the area where the generator is being used. 40thly, when installing a transfer switch, it is important to consult with a qualified electrician to ensure that the installation is done properly and safely. A qualified electrician can provide you with the information and assistance you need to ensure that the transfer switch is installed and operated in accordance with all applicable codes and regulations. Always prioritize safety when working with electricity. If you are unsure about any aspect of the installation or operation of a transfer switch, consult with a qualified electrician. Electricity can be dangerous, and it is important to take precautions to avoid electrical shock and other injuries. When moving the neutral wires, ensure they are connected to the appropriate neutral bar within the transfer switch or subpanel. The neutral bar should be properly bonded to the ground. Do not connect neutral and ground wires together on the load side of the main service disconnect, as this can create ground loops and potentially dangerous conditions. Confirm that the voltage rating of the transfer switch matches the voltage of the electrical system. Using a transfer switch with an incorrect voltage rating can damage the switch and the connected equipment. Properly torque all connections to the transfer switch and other electrical components. Loose connections can lead to overheating and potential fire hazards. Use a torque wrench to ensure that connections are tightened to the manufacturer's specifications. Consider the environmental conditions where the transfer switch will be installed. If the transfer switch will be exposed to moisture or extreme temperatures, choose a transfer switch that is rated for those conditions. Install the transfer switch in a location that is easily accessible for maintenance and repairs. Ensure that there is sufficient space around the transfer switch to allow for safe and easy access. When connecting wires to the transfer switch, use the correct type and size of wire connectors. Wire connectors should be rated for the wire size and type that is being used. Ensure that the wire connectors are properly installed and tightened. After completing the installation of the transfer switch, thoroughly test the operation of the switch. Verify that the switch transfers power correctly between the utility power and the generator power. Check the voltage and amperage of the circuits that are being powered by the transfer switch. Keep a detailed record of the installation of the transfer switch, including the date of installation, the model number of the transfer switch, and the wiring connections. This record will be helpful for future maintenance and repairs. Periodically inspect the transfer switch and the wiring connections to ensure that they are in good condition. Look for signs of damage, such as corrosion, loose wires, or overheating. If you find any problems, have them repaired by a qualified electrician. Follow the manufacturer's recommendations for maintaining the transfer switch. This may include lubricating the switch mechanism or replacing worn parts. Before performing any maintenance on the transfer switch, disconnect the power to the switch. This will help to prevent electrical shock. If you are not comfortable performing maintenance on the transfer switch, have it done by a qualified electrician. Keep the area around the transfer switch clean and free of obstructions. This will help to prevent accidents and make it easier to access the switch for maintenance and repairs. When using a generator with a transfer switch, make sure that the generator is properly grounded. This will help to prevent electrical shock. Use the ground rod and connect it to the generator's grounding terminal. Follow all safety precautions when operating a generator. Generators produce carbon monoxide, which is a deadly gas. Operate the generator in a well-ventilated area and install a carbon monoxide detector in the area where the generator is being used. When the utility power is restored, switch back to the utility power. Allow the generator to cool down before turning it off. Store the generator in a safe place when it is not in use. Keep it away from flammable materials. Disconnect the battery if the generator is not going to be used for an extended period of time. This will help to prevent the battery from discharging. Check the oil level and add oil as needed. Use the type of oil recommended by the manufacturer. Check the air filter and clean or replace it as needed. Check the spark plug and replace it if it is worn. Keep the generator clean. Wipe it down with a damp cloth to remove any dirt or debris. Have the generator serviced by a qualified technician on a regular basis. This will help to ensure that the generator is running properly and safely. Remember to always consult with a qualified electrician for any electrical work to ensure safety and compliance with local codes.